Good morning. Today I will discuss about the numerical based on the working of the Hydra pulper. Hydra pulper is very important machine of a stock preparation section, and the persons working in the industry or studying the paper technology must know. So Hydra pulper is basically a mixer which is designed to make a uniform slurry of the fibers. And here I've given a simple numerical that is based on the actual industrial data. Like the Hydra pulper is receiving the pulp seed, or it may be in the form of the pulp granules, which is having the 20% solid percentage. That means the 80% is the water. So generally, after manufacturing of the pulp, it is stored in the semi-dried form. So dryness will be in between 15 to 20%. And then, depending on the utilization of different paper machines, it is sent to the stock preparation section of different paper machine, and the first equipment that will be receiving the pulp will be Hydra pulper. So it will be taking the pulp at the medium consistency, like here it's coming at the 20% solid percentage, and then diluting to 5% solid percentage using the dilution water at the normal temperature of 35 degrees Celsius. And this industry is especially manufacturing the tissue paper at the production rate of 300 tons per day. This production rate is given on the OD basis, oven dry production rate. A Hydra pulper system of stock preparation section is receiving the pulp sheet at 20% solid percentage and diluting to 5% solid percentage using dilution water. Again, the retention is given. The retention of the solids on the paper machine is 90%. Then calculate the amount of water required and the amount of pulp sheet added in the pulper on daily basis. So there are two parts of this question. First one is you have to calculate the amount of water that is required for making the slurry. And second one is the amount of pulp sheet that is added on daily basis, or requirement of the pulp sheet coming from the pulp mill on daily basis here. So basically two parts are there. So let us see how to calculate the amount of dilution water and how to find out the total amount of the pulp requirement on daily basis. So here the production rate is given 300 tons per day. This is the production of the paper machine. That means after having all the accountability of the different types of the losses, because when you are doing the manufacturing, it's well known, process is not 100% close. Some of the fibers will be escaping from the joints, maybe the leakage from the pump, leakage from the pipelines. Again, during the filtration of the wire section, some of the fibers will be passing through the wire holes, and again some fibers will maybe being on the different other sections like the pulp section, or in the pulper where we are handling the grow pulper. So whenever doing the recycling, 100% recycling not there, some part will be lost. So we are considering overall solid retention on wire is given 90%. So whatever we are adding, 90% is converting to the final product. So basically, we have to find out the higher pulp solid as the raw material, the 300 final production. So certainly the input pulp will be higher. So here the amount of pulp in oven dry basis required for paper making will be 100 divided by 90 multiplied by 300. So this will be 333.33 tons per day. Then the incoming pulp to Hydra pulper at 20% solid. So the amount of the pulp coming to the Hydra pulper, again the total amount is 100, then only 20 is a solid here. So here the total solid required is 333.33. So how much will the pulp that will come to the Hydra pulper? 100 upon 20 multiplied by 333.33, that will be equal to 1666.65 tons per day. Now the third step will be the outgoing pulp slurry from Hydra pulper has 5% consistency. So the total amount of pulp outgoing from Hydra pulper will be 100 divided by 5 multiplied by 333.33. Because here you can see the 100 is the total amount, whereas the solid will be now 5% only. The same mass is diluted by water, so now the solid is only 5 and total will be 100. So we are calculating the total mass, total amount of the slurry. So, and this will be equal to 6,666.6 tons per day. Now we can calculate the amount of water that's being added in the Hydra pulper. That will be C minus B. This is the total after dilution. This is the total before dilution. So if you take the difference, it will give the amount of the dilution water. So this is the dilution water. It will be coming 4,999.95 tons per day. That means nearly 5,000 metric cube or cubic meter water will be required. 5,000 cubic meter water will be required for dilution in the Hydra pulper. And that's why the paper industry is considered to be a highly water intensive or water consuming industry. The amount of the pulp added per day in pulper will be 333.33 tons per day. This is directly coming from the A. You already calculated the amount of total solid, and this will be basically based on the production rate and the retention percentage. Like here, we have calculated retention is 90%, so 100 by 90 multiplied by production rate 300. And this is giving you the 333.33 tons per day. In this way, we can do the calculation at any point where we are doing the data. All right, so if you're not having any doubt, then I can give you some of the concept of the press section of the paper machine. All right, so I've already sent you some of the study materials on the press section. So basically the press section is again the extension of the dewatering process or removal of the water that is being removed on the paper machine. So paper machine has 3 sections: wire section, press section and dryer section. All the 3 sections are having the that means in every 100 kg of the paper, only 5 kg will be the water and 95 kg will be the solid air. Right, so here comes the role of the press section. It's a mechanical device which is removing the water by pressing action, mechanically placing the paper in between the solid roll and the press felt. And the press felt basically it's doing the two jobs. One is it's supporting the paper when it's moving through the press section, and second one is it is absorbing the water from the paper. Otherwise, it will develop the hydraulic pressure or back pressure will be developed and it will burst the paper. And that's why you will find sometimes in industry when we are having the poor quality of the press field or dirty press fields which are not cleaned properly, pores are not open, or if you are not applying the good vacuum, generally we will be having the breaking on the press section. Paper will be breaking from there. And that's mainly because of the back pressure that will be developed. Right? So what we have to do, we have to maintain the good quality of the press field. Pores should be open. It should be having the good sponge-like quality, or should be soft in nature to absorb the moisture. Again, the open area wide should be very high. Generally, it's having the 60 to 70% of the wide area, open area in which it can store the water, absorb the water, and then when it's coming out of the pressing area, this water is again removed with the help of the vacuum. Vacuum tubes are there that will be sucking the water from the press field. Right? So basically, the press section will be increasing the water from nearby to, you can say, the 20% of the solid percentage to 50% of solid percentage. So wire will be increasing the solid percentage from 1% to 20%, then press from 20% to 50%, and then dry will be increasing the solid percentage in paper from 50% to 95%. Right, so press section is basically using the low cost removal of the water from the paper. Right, so if we compare the wire section, press section, and dryer section, then the easiest one is basically the wire section, in which the removal of water is easy because there a lot of the water is there. Once the water is reaching 18 to 20% solid percentage of paper, the removal of water will be very difficult in the wire section, because even very strong vacuum cannot remove the water beyond 20 or 22%. Cost will be very high. So we need another process to apply the mechanical pressing. We apply the press in between the two solid rolls. We pass the press felt and paper there. And due to the high pressure, the water will be shifting from the press to the felt. So basically, the water is, it's not totally removed by filtration or any other process. So basically, we are just shifting the water from the press area or press paper area to the press felt area. We apply the pressure from top, so water will be moving from the paper to the felt there. And then we are separating the felt and paper, so water will be carried by the felt and paper will be having the higher dryness. That is the mechanism. And the main problem is the crushing of the paper there. You apply the very high load. Normally, the engineers try to increase the load in the press section to increase the water removal. But what will be happening? If you increase the load beyond certain limit, then it will be crushing the paper and paper will be breaking from there only. It's in the wet condition, having only 20% solid there. So if we are applying the very high load, it will be crushing it. That's why generally we are doing the pressing in 2 or 3 different presses. First press, second press, third press. Normally at least 2 press will be there in every paper machine in all the paper industry. And the main reason is we are gradually improving the load with the increase of the solid percentage. So first press having slightly lower pressure, lower load will be applied. In second press, we apply the higher load. Right. So in this way, we increase gradually the solid percentage that will be going up to 45 to 50%. And beyond 50%, generally the removal of water is very difficult in the press section by mechanical load application. That's why we are going for another different unit operation, different process that's called as the dryer section. Paper drying using the steam heating or electrical